In section 3.2, we get law of cosines. So this is going to allow us to solve triangles where we are given a side, angle, side, or just three sides and no angles. So here's what the law says. You can find a good way to remember that. A couple of patterns that are here in the standard forms, that the side that the formula is solved for is going to be the one that's opposite the angle. So this side is angle, this side is this angle, if that helps. The alternative forms, just the same equations but solved for the cosine of the angles instead. So this would be helpful if you're trying to find the alternative. All right, so let's get into an example. In this problem, we are given three sides, no angles, and we're trying to find all the angles. So it's a good idea to find the angle that's opposite the longest side first. So in this diagram, that would be B. So let's find angle B first. So we're going to use the law of cosines, the ones that solve for cosine B. So this cosine B is equal to A squared plus C squared minus B squared over 2AC. And we know all this, right? So we're just going to plug them in here. A is 8, C is 14, and B is 19, divided by 2 times 8 times 14. So putting that in my calculator, I get, I'll just leave it as fraction, because to get angle B, I've got to do the inverse cosine to both sides. And you want to notice here that cosine B is negative. So that's telling me that we're in this quadrant. And so this is an obtuse angle. So it's bigger than my. And that's what I get when I put it in my calculator. I get 116.803. So that's what I get when I take cosine inverse of this fraction. And it would be similar if you got a decimal. Just don't round too soon. Every time you round, you lose. So from here, now I have enough information that we could use the law of sines to find angle A. So let's use law of sines to find angle A. All right, so that would look like sine A over A equals sine B over B. And that is, we know A, we don't know capital A. We know side A is 8. Now we can fill in for angle B, and we know side B is 19 feet. So now solve in for sine A. I gotta multiply both sides by 8. We've got 8 times sine 116.80 degrees divided by 19. And I get, and actually it's gonna be best if you can put this whole thing in your calculator and take sine inverse of this whole thing. That way you don't have to round and you're not losing accuracy. So if you take sine inverse of this whole thing, if your calculator, not gonna do well with that, then of course you can evaluate that right side and then do sine inverse after. But it just makes it a little bit more accurate if you don't have to round. All right. So another helpful fact is that a triangle is only going to have one obtuse angle. So I know that this angle here, this angle A that I'm trying to find, should not be obtuse. Must be an acute angle. Antagonist. So 22.08 if I round it to the nearest 100. Round it to the nearest 100. All right. So put the triangle. So it's only one piece of information left. And that is the measure of angle C. And I can do that without any of these laws because I know A plus B plus C has to equal 180 degrees. So C has to be 180 degrees. A plus B. That will give me 14.112. And now I have solved the triangle. I found all three. Also in this section, we are given another formula to find area. So we've got The first one you learn 1/2 times the base times the height. And then we've got the one that we used for obtuse triangles in 3.1. And now we have another using all three sides of the triangle. So this formula also involves S, and S is just A plus B plus C divided by 2. So all side lengths added together divided by 2. So a quick example using Heron's formula. We're given three sides. We need to find the area of this triangle. Heron's formula involves side A, side B, side C, and also S. So the only thing that we're not given here is S. We need to find that first. S, A plus B plus C divided by 2. And for this problem, that's 3 plus 2. Adding those together, I get 1, 8 divided by 2, which is 84. Right, so then the area is the square root S times S minus A times S minus B times S minus C. I know all of those things now, so I'm just filling them in. 84 is S. All right, so using order of operations, I'm moving inside the parentheses first. That's 41. And 30. Right, next I'm going to multiply and then do the square root last. Using your calculator, you can put it all in one step and enter place. So I get 1131.89 an area in a square unit. So square